Hello and welcome to another video. In this video we're going to be working on maximum score for removing substrings. And this one you're given a string s and two integers x and y, and you can perform two types of operations any number of times. Remove a, b and gain x points, or remove b, a and gain y points. And you want to return the maximum you can gain after applying the above operation on s. So in this first example, you're going to remove this guy for 5 points. And then you can also remove like this guy for another 5 points. And then you can remove this b and this a, because they're together now, for 5 points. And then this right here for 4. So you get 19 total. And the second example, we can remove, so b is worth more, so that's the one we're going for. And that's kind of what you're trying to get out of these examples, like what's a pattern. So you're going to want to remove the one with the bigger score. So we can see like how many ABs can we remove. So we can remove this guy. Then we can also remove this guy over here. Then we can also remove this guy and this guy. So that's 4 of them, and then we're going to be left with AA, X, Y, B, B, and then there's nothing you can do there. So for these types of problems, I said before, like you have something you can do, and I think these problems are kind of cool because like you can't really study for them. It's more just like, here's some random operation that you can do. Now find the pattern. And so what I recommend for a lot of these is like try this on a few different strings, figure out like what's the pattern and is there some kind of like shortcut? Like is there an optimal operation or something? And basically when you do that, you realize a few things. So you realize if there is a non-A or B character, then I can't use both sides of it, right? So what I mean by that is like if there's some random string, let's just call that s, and then there's like an x and then some random string s again, you can't use characters from this s and this s, right? Because you can never get rid of this x. So anytime you have a non-A or non-B character, that character will be a separator. So right away we know that like if we have characters that aren't A's or B's, like we can't combine things from both sides. Now another thing is let's say your only operation was AB. Like you can only use AB, you can only use this guy and not the other guy. Then what would you do? So then you can just use a stack, and what that would look like is anytime you hit an AB, you just pop and get some score. So it'd be like CD, B, C, B, B, A, and then we have A, A, B, and then we're like, okay, we have an AB here, so we could pop, one pop, and then I think it's like this. So we have another pop, and then I think we're done. So basically, that one's pretty straightforward if you can only use one. But with 2, you want to recognize that you want to use the one that gives you more points. And so you're going to have situations where you can take both approaches. So if you have like this, for example, you can use BA or AB, and you can only use one of them. So you're going to want to use the one that gives you most points. And also these constraints, you can notice like the number is pretty big here. It's not like 20 or something. So you can't do something super inefficient. You have to have like an n or n log n solution. And that gives you enough intuition to look for a greedy solution. And so what you can recognize, and what I recognized after doing this a bunch, is basically for all strings, we can just greedily look for the operation that gives us the most points. And then once we're done with that, we're going to have only one type of string left over. So let me show you what I mean by that. So let's say AB is worth more than BA, right? Like that gives you a higher score. So if AB is worth more, you're never going to have A's in front of B's, right? Because we're just going to pop all those off the stack and get those for points. And anytime we reach a non-B or A character, we're going to like stop. So the only thing we can really have left on our stack is some number of B's followed by some number of A's, right? This is the only sequence we can possibly have, because any other sequence, like if we have a B here, we're just going to pop. So whatever is worth least, in this case is BA, once we greedily pop the one that's worth the most, we're just going to have a stack left of some number of B's and some number of A's if this is worth the least. And there's no other thing you can have. Like you can't have a B here because you'll pop. You can't have an A here because you'll pop. You can't have like an A between them because you'll pop. You can't have a B here and so on. So once we have this left over, it's pretty easy to figure out like how many things we have left. All we have to do is just count the number of B's and A's. So once we have like a separator, or we can't do the greedy operation anymore, we just count the number of B's and A's. So here we have 4 B's and 4 A's. And if we had like more A's, like in order to pop these, you're gonna be able to pop as much as you have each character, right? Because you can just pop from the middle, pop from the middle, pop from the middle. So you can keep popping until you're out of one character. So we can just get a count of B's and A's, and then whichever one we have least of, so in this case we'll have 7 A's. That's how many operations we can do, and this is the bad operation, right? So in this case, we can do BA 4 times. So the idea here is we greedily try to look for the one that costs the most. Then anytime we have a character we can't use, we just take whatever we have left and figure out, okay, now how many times can we use the bad operation? And then whenever we're done and we can't use the greedy operation as well, we'll just do the bad one. So we're going to write a function to calculate like how many B's and A's we have in a string. And then otherwise we can just greedily do the one that's better. And you can figure this out, like I said, just by trying a bunch of examples and being like, okay, well, I can only have strings in this format if AB is bigger than BA. And if BA is bigger than AB, then I can only have strings of the opposite format, some kind of thing like this. You can't have a B in front of an A because you will always greedily pop. You can't have a B behind an A, so you'll basically only have this format. And you can't have any other characters because you will just stop. So now that we know that, let's go through these examples. So here, BA is bigger than AB, right? That's worth more points. So this is operation 2. So we're gonna add characters onto the stack. Whenever we have a character that we can't use, we're gonna take our current stack and figure out how many points is that worth. And then we're just gonna greedily keep doing this until we're done. So our stack will have a C. So as soon as we hit a C, we're gonna say, okay, well, let's actually just show a stack here as well. So here's our stack. So we're gonna try to add a C, and we're gonna say, okay, C can't be A or B, so we're gonna take whatever our stack is and get a score. It's an empty stack, so it's not worth nothing. Then we're gonna get a D. I guess maybe you can do something like this. Just move it. Yeah. Okay. So we're going to get a C, not worth anything. D, same thing, can't be in here. Now we have a B. So we're going to put a B in the stack. Then we're going to have a C. So we're going to say, okay, now we have to take what our stack is and calculate a score. Here we only have one letter, so we can't have anything. We need to have both B's and A's, so this is worth nothing. Then we're going to have a B. And then we're going to have another B. And remember, we're going to greedily take the BA, and that's all we're going to do. So here we have an A, so we have a BA, so we can pop, and that's worth 5 points. Then we're going to be at another A, so we pop again, 5 more points. And then A, B, A, pop again, 5 more points. And finally we put on a B. And we can't do any more greedy operations, so now we take whatever we have left and calculate how many B's and A's we have. We have one of each. So like I said, the format we're gonna have left over is A times some X value and B times some Y value. So in this case, we have one of each, so that's worth 4 points, so we'll have 19. Okay. Now let's do the second example. Same thing. So in the second example, though, it's reverse. We want AB instead of BA. So this is the one we're going to greedily take. So we're going to say, let's put on A, then let's put on A, then let's put on B. We have an AB here. So pop, and that's worth 5 points. Then we're on the second B. I guess maybe I can just do this or something so I could show where we're at. So we're on the second B here, and then we're going to put that on as well. And that's another greedy pop, so that's worth 5 points. So we have 10. And then I guess what I could do is I don't need this constraints thing anymore. So I could just do this. Okay, now we go to, and let's move this down maybe. There we go. Actually, I should do this. Okay, so now we're on this, so we have the 2 A's and 2 B's that we just did that were worth 10 points. So now we go to the next letter. So we have A, and another A. Oh, let's get rid of this. Then we have an X, so that's now we take what our stack is and calculate our points. So we have 2 A's and no B's, so this is worth nothing because we need B's. Y is not in here either, so we just keep going. Then B, B, A, A, and now we get to this B. So this is our greedy pop. And then we're gonna get 15 points. And B again for our last one and do another greedy pop. So 20 points. And now we have 2 B's, we have no A's, so this is worth nothing. So hopefully that makes sense. You just figure out which operations are worth more, greedily do that with a stack. And then anytime you hit a separator that you can't include or the end of your word, you just calculate how many A's and B's I have. And I have to have that exact format of the one that's worth less because there's nothing else that will work. Otherwise you would have popped already or hit a separator or something. So that's what we're going to code, decent amount of code. So let's first have a result. Then let's make a stack. And it's going to be a list of characters. And then basically we need to figure out like what's the string that's worth the most, so we can call it like good value or something. I have pretty bad, they're a good string or whatever, the one that's worth the most. So if X is greater than Y, then it's going to be AB. Otherwise it's going to be BA. And if they're tied, you can pick whichever one, doesn't matter. Okay. So now we need to know the first character of this string, and that'll tell us like what we're looking for. So we can say character, first character, or you can just keep using the index, is fine too. Either one. I guess, yeah, I guess we can just use the index and it's fine. So we don't need this. So we need the value that's worth more and the value that's worth less. So we'll have like small total or, you know, whatever. And then this will be, because we need to know like which one is worth more, which one is worth less. Okay. You can also technically not include this and just base it off the string. Like if your good val is AB, then it's X. Otherwise it's Y, but whatever. Doesn't matter. Okay, so the big value will be the maximum of those. Okay. So now we're going to go through every character and we're basically going to look for either the first character in here or the other character or a separator. So we'll say for character C and okay. So if the character is not an A or B, which means, so alphabetic, I think you just do this. If it's not A or B, then we're gonna call a function that we're gonna write right after this to give us the total for this thing. So we'll say result plus equals this function that we're gonna write called calculate. Just call it calculate remaining stack or something. So it's going to take in the stack. It's going to take in the good val and the small, because this will be the one that's worth a small amount, right? Like if A and B is worth less, then you're going to have a bunch of A's and a bunch of B's. Okay. Otherwise, if the stack is not empty, so this is where we check for the greedy case, and C equals good val character at 0. Actually, yeah. Oh, sorry. So it needs to be the other one. So like if our one that's worth more is AB, then this actually needs to be the second character, and stack get last needs to be good val char at the other one 0. Okay. Yeah, actually, let's see. Stack that get, oh, this is wrong. So like this. Okay, so if the character is whatever our value that's worth the most, the current character needs to be the second one in there, and then the last character in the stack needs to be the first character in there. So if A is B is worth more, the last character in the stack needs to be A, and then the character we're putting in needs to be B, and so on. So this is the case, yeah, like we have the greedy match. So if we have the greedy match, we can just pop the last character. last. And then we add, so this is going to be the big one because this is the one that's worth more. And then otherwise, we basically have a character that we can possibly use later, but it's not a greedy match, so we just add to the stack. Okay. And at the very end, we have to do this other operation again. So if stack is not empty, we have to get the rest of it and calculate how many points that's worth as well. So it's basically going to be the same function again. So that's why it's better to write it, because you're going to use it twice. And then finally, you're going to return results. Okay, so all this function needs to do is just calculate the number of A's and B's and then give you the minimum of it times the small value. So we can write it here. Calculate remaining stack. It's going to take a list character stack. And then it's going to take good val. So this is string. And int value, like what's that worth? Okay. Should be fine, I think. Okay. So we basically need to just calculate how many A's and B's we have, so we can say like A's, as might be A's or something, I don't know. Okay, equals 0. B's, best character names you can have. Okay, so C and stack. So basically we can just say if C equals A, then A's plus else B's plus. And we just return the minimum of the two times the value that it's worth. Okay. So yeah, and I think it's pretty reasonable to figure this out. Like I said, the best way to do this problem is just you have an operation, play around with it, and see if you can find a greedy solution. And almost always you can find some kind of, like maybe you won't find a linear, but you'll find, oh, like it simplifies down to this thing. And yeah, these problems are kind of nice because you're not just like memorizing an algorithm. Okay, I screwed that up. Let's see what we did wrong. So stack, this is fine. Mathemax, okay. So if the character is a bit bigger than B, we just calculate the stack. That should be fine. If the stack is not empty and the character is 1, that should be fine. Should be fine. So I'm guessing here or something. So what do we pass in? We passed in. Actually, we don't need to, now that I'm looking at it, we don't actually need to pass in the character. It doesn't, oh, actually, wait. No. So I think this is redundant. Yeah, this is definitely redundant because the string can only be in one format. Like I said, it can only be, it can only be in the format of the string that costs the least. So if the one that costs the least is AB, it's going to be like A's and then B's. It can't be anything else. So this is redundant, so we can get rid of this. But we still have an error, I think. Yeah, so this is redundant for sure. I don't think we even used it in our function, but I think we still have an error. Yeah. So let's figure out where that is. Okay, so I think our issue is, so whenever we do this like stack calculate, we have to reset the stack. So that's what we're missing. So we got a stack reset or something, delete, clear. There we go. So we just never ended up clearing and we counted too many times. Okay, there we go. So this is, oops, linear time because we're traversing once, and space is linear because we have stack. Okay, hopefully this one makes sense. I think it's a little challenging for a medium problem, but I think this pattern is pretty straightforward to come up with. Like you just figure out like, okay, if I have this thing, in the examples, they're always trying to pick the bigger operation, the one that's worth more points. So maybe there's something there, and I can't just like, there's way too many combinations to just like randomly pick like, do I take this or something? You need to simplify it down to more than that. So I actually don't know how you would do it without this, like with some dynamic programming or something. I think that would be too slow. Like because there's like a lot of things you can do. And if you did do dynamic programming, you're like removing from the middle. I guess what you'd have to do is you'd have to like pass in a start and an end index. And then if you remove from the middle, you would just break it down into like this section and this section and so on. Yeah, I guess that would probably work, is how you'd remove from the middle. Some kind of dynamic programming, you remove from the middle and pass in a start and end index. And then if you remove from the middle, that breaks down into the left and the right of that section. Yeah, that actually makes sense. But obviously, I don't know if that would pass or anything. So yeah. So hopefully this is helpful. If it was, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.